Hello all, a very good morning. Welcome to Faculty Development Program on Data Science. Let's get started. A quick recap. So what we have discussed yesterday. So yesterday we discussed about two algorithms. So one is on k nearest neighbor, KNN. So KNN can be used for classification as well as regression. And the KNN mechanism is, so when you have the data points, lot of data points like this, and in order to classify a new data point into one of these classes, so just imagine this is one class, okay? So others are the other classes. Let's say, so if you want to classify a new data point, so I would find out the distance between this new data point to all the data points that are there in the data set, historical data set. So this new data point is near to which of these data points? So let's say if this is near to this data point, then simply I'll assign this class to this. So let's say that is yes. So that's how the KNN would work. So when you say the distance will use Euclidean distance method, and based on that we'll identify the distances whichever the data point is very near. So if that is a case, that is 1 NN. If we consider only one data point which is very near to the new data point, then that is called as 1 NN. And if it is 2 NN, the nearest two data points would be considered with a new data point. So like that, we will identify which is the best NN based on the trial and error method. So yesterday we have seen grid search method. So in that we have given series of k values, out of which I think 19 or 13 is a best k value that we have seen. Right? So this is the k nearest neighbor algorithm. And yesterday we have seen the healthcare data set, the use case in using the k nearest neighbor algorithm. Then we have seen the neural networks. So we have understood the artificial neuron and how the artificial neuron works. So how that resembles how the biological neuron would work, right? So the neuron is like this, and when you see a neuron, so neuron has got to do two jobs. One is the summation, the other one is activation function. So what are the values that comes, the input values associated with the weights W1, W2, W3. Okay. So this would be a function of, okay, so whatever the summation function gets, so here we'll get the x1, so I'll say xi wi 1 to n. So summation and multiplication with the corresponding weights, this would be sent to the function, activation function. So I can summarize like this: the function of, so xi wi. So this is my output. So I can define this function. So what this function? So like step function yesterday we have discussed, or it could be a ReLU or TANH or Gaussian or whatever. There are many activation functions are there. Based on the definition of this activation function, the output would be delivered. Okay. So this is a simple neuron, and the simple neuron or perceptron so cannot solve the complex business problems such as the data points which are in non-linearly separable. So non-linearly separable, yesterday we have seen. So this is one class and this is another class, a class within the class, right? So for this, so a non-linear decision boundary is required to separate these classes or to form the pure regions. So in that case, we need multiple perceptrons. So that gives us the idea of the multi-layer perceptron. So the multi-layer perceptron is like this. when we use the perceptrons many in layers approach. So this one is called as input layer and this is output layer. So whatever the neurons so that are there between these two layers are called as hidden layers. So these are hidden layers. These are first hidden, this second hidden layer. And how many number of hidden layers we have to use for a given problem and how many number of neurons should be used in a hidden layer is a hyperparameter tuning. That means we have to identify based on the accuracy and based on the overfitting and underfitting of the model. So that we have to decide while building a model, right? So this we have discussed, and then we discussed about something called as back propagation, multi-layer perceptron with back propagation. So what is that? The back propagation is, okay, right. So this network, so initially we will assign the weights randomly. So this is W1, W2, okay, W3 like that. So randomly the weights would be assigned. And when I give the input, I'll get the output. So this output would be compared with the predicted. This is actual output and we'll compare with the predicted output. Difference between this is called as error. Okay. And our objective, our network objective is to minimize this error so as possible as minimum. So in order to minimize this error, so this error would be sent to the network and identifies which weight is contributing how much to this final error. So that error will be sent back to this, and the new weights would get computed based on how much each weight is responsible. With the new weights again will send the data and this error would go down in the subsequent iterations. So there would be many iterations, and with this subsequent iterations the error would tend to go down. Right. So this is basically called as back propagation. And when you say I'm building neural network, so by default you are building the back propagation method only because that is the most efficient, most popular method at this moment. Right. And yesterday we have seen a few examples and simulation, one demo on how the neural network would solve complex business problems. Okay. Yeah. So I would like to give you a few more little more information about the neural network. Okay. Now coming to the research area. Okay. If you talk about the most of the research so is being conducted in machine learning and especially in deep learning. Okay. In deep learning, so we have first the artificial neural network. So that is what we have discussed yesterday at a high level, artificial neural network, and there's a lot to discuss. Okay. And in some universities there is a separate subject semester, entire semester they'll teach the deep learning and neural network. Right. So using this neural network we can solve the numerical examples whatever we have seen yesterday. And how do we solve the image processing techniques? Okay, image processing. So we have images, we have videos. How do we analyze these images? Because these images comes under unstructured data. So if you leave this and if you leave the videos, okay, so they also contains a rich information. And if you leave like that, and we are losing a good amount of information, right? So it is very important to analyze the images and analyze the videos. What are the use cases? And we keep on reading in the newspaper. Governments are using the CC camera feed to identify culprits. So they'll install so on the railway stations and crowded areas, and they'll find out so any culprit is going on there. How do they do that? So they'll take the images of all the people, okay, and they'll take the faces. So these faces would be compared with the databases, criminal database. So this is called as face recognition. Okay. And so there are many. For example, I can get the CC camera feed, okay, so continuously in a street, and I can identify any suspicious activities going on. There is a person who left luggage so on that road so for at least 30 minutes or more than 1 hour. So that is a suspicious activity. Or based on a person is walking on the street, based on that postures and gestures, I can find out whether that person is threat to the society, or that person is so has intention so to beat someone else. Right? So based on that CC camera feed, I can find out. So that's a video processing. And image processing, I can take the image and I can find out what are the different objects are there in that image. So these are all the possibilities or use cases of image processing. And also in a traffic signal, for example, I can find out how many number of vehicles are passing through that signal. And also I can capture the number plates of the vehicles who violate the traffic signals. So these are the things actually possible using image processing and the video analytics. And this can be possible using a technique called convolution neural network, CNN. Convolution neural network is specifically designed for this. Okay. And we have a different predefined architectures in this convolution neural network. You don't have to build the models from the basics, from the scratch. So already some people have built some architectures, like so we have so from Google we have architecture, so we have AlexaNet. Okay. So there are 5 to 6 very popular architectures are available. Those are based on the CNN, and directly we can use those architectures. That means you don't have to build the CNN from the scratch. And this is called as transfer learning. Most of the research is going on in this area, transfer learning. That means we build a network on certain problem. Okay, so there is one problem, now build a network here. Okay, and this network I can use for other problems also by modifying little bit. So that means I'll remove the initial layers and the outer layers. I'll use the hidden layers, and I'll use these hidden layers for the to solve my problems. So the already existing network model, using this already existing model to a different problem, is called as transfer learning. Okay. So if you want to explore, please go ahead. And the other thing is the sequence data. So sequence data is basically, so if you capture the data in a sequence, like for example, time series data. So if you capture the data every day, one data point, day one, day two, day three, like temperature data, or hourly basis, or seconds, or minutes, any sequence, month or quarter or year. So just we need a sequence. So sequence data analysis so can be done using RNNs, recurrent neural network. Okay. So in this RNN we have something called as LSTM, long short-term memory. So this is actually a popular, again, efficient method to solve sequence problem, to build the forecasting algorithms. And also the text analytics. The text also a sequence, right? So that means if you are speaking a word follows the other word. So that is also you can consider sequence data. That means text analytics. So you can use LSTMs. Okay. And we have something called as GANs, generative adversarial networks. So we have a reinforcement learning. Okay. So we'll have a framework, we'll have a policy, and we'll have a reward system. And based on that, the agent, whatever the agent that we create, would learn based on the as per the rules of the framework. So all those things would happen. These are again a research area. A lot of research is going on in this front. Okay. So probably you can explore further on these things. Okay. Right. So let us get into today's topic, that is text mining or NLP, natural language processing. So what is the objective of the text mining or NLP? So discover people opinion, emotions, and feelings about a product or service. The customers of any company. Okay, so the company is providing some services or some products. They are selling some products. The people who utilizes the services as well as who consumes the products, so they either might be happy or not happy, and also in between. So I can get the information: customer satisfaction, highly satisfied, satisfied, neutral, not satisfied, very badly dissatisfied. Right? So these are the different the satisfaction levels we can identify. So we can get the customer the ratings, right? So let's say for example we have 1 to 5. So I can roll out this form to customers and I can get the ratings. Hey, whether the customers are so not happy, customers are happy. So 1 or 2 or 3, 4, 5, like that I can get that. But this is a numerical information. So this numerical information is not sufficient to understand the customer pulse completely. Because for example a customer has given us one rating. Okay, so it's clear that so that customer is not happy at all. But why that customer is not happy? Can we get more information about that customer unhappiness? So in a product, in a mobile phone, for example, because of what component? So the customer is not at all happy. The customer is very happy, extremely happy. About what actually? About what service customer is happy? So if I want to understand more deeper into the customer pulse, the customer opinion, then I have to go for text mining. What we do? So we will ask them to write some overall feedback. So not only the overall rating, we'll ask them to write overall feedback like this. Okay? Now let's say you have so 100,000 customers reviews are there like this. So if it is numerical information, so we can quickly summarize using the numerical methods, these statistics or descriptive statistics, the idea. So on an average, how many number of customers happy or not happy. But what if actually if you ask them, give the feedback, overall feedback about your product or service, and there are 100,000 customers have given you this feedback. So would you go ahead and read one by one? So that is not practically viable. So it is not practically possible, but it's not a viable option for companies. They have to spend a lot of time, right? And do we have any automated method? So that summarizes all customer feedback and gives us the idea so about what people are discussing, whether they're discussing about the quality or they're discussing about, if at all, for example, mobile phone context, this touch screen, the people are happy, or battery, or their response, or look and feel, about what actually people are happy or about what they are not happy. So that I can get. So when we do this text mining on this text data. Right? So this is where actually the text mining or natural language processing is very helpful in various domains in for various companies. Okay. So that is also called as sentiment analysis. Okay. So that is also called as sentiment analysis. So the sentiment analysis is a computational task. So automatically determining what feeling that customer, writer means the customer expressing in the text. So we can read, okay, so we can get to know so what that writer or customer so has written. But that is not our intention. If you have in bulk thousands of or lakhs of, you can think of Amazon. So the product owner so wanted to understand so how customers are reacting. So once they use the product, they definitely leave Amazon or Flipkart websites. And how many reviews would be there? Thousands of reviews would be there. And the product owners, they'll go read each and every review. No. So that is not a feasible option. So that is where we'll apply this sentiment analysis of text mining. Sentiment often, so we would identify as a binary distinction. That means are they positive or negative? So not only whether they are positive or negative, we also have some more. So we can also dig deeper into this positiveness as well as negativeness. So we have something called as emotions. So scientifically, or the psychologists identified humans will have 8 emotions. So whatever the feeling that you express, so that feeling can be tagged to these 8 emotions. So we'll discuss what are those 8 emotions, like fear, joy, anger. So like this, we have 5 more emotions, and whatever the feeling you express, okay. So that those feelings can be tagged to fear or joy or anger or sadness or whatever it is. We have 8 emotions. And along with these 8 emotions, so we will score that review and we will understand in a better manner. Right? So that is what actually sentiment analysis, also called as emotion mining. And so the sentiment analysis, so will have lot of applications, analyzing the social discussions around certain topic. Of late, so lot of the political parties, not only political parties, all the companies, even product based and service based companies, they would like to understand so how their reputation in the public. So of late, people are using the social media, the digital platforms like anything. Okay, and if I analyze the tweets, the people would tweet about the party or the company or a movie or whatever it is, a product, right? So a company has launched a product, and then the people would respond to that product, whether they are happy about the product, they are not happy, or they are praising the company, or they are cribbing, scolding the company. So all this information, so they'll tweet on daily basis, and then I can get these tweets, and I can give a score. I can see whether the sentiment is increasing or decreasing, or whether they're happy or not happy. I can also assign the time period. Hey, first phase they are very happy here. So there is actually a dip here, and again it is continuously going down. So that means I can understand, okay, so this time period customers are happy, that means we provided services in a very better manner, good manner. After that, somehow some things have changed in the company, the services degraded and customers are not happy, right? So this kind of analysis we can get. And also, even for the political parties as well as the leaders, so we can also identify so how their reputation, so in the citizens. So evaluating survey responses, right? So we can roll out the customer surveys, feedback forms, and what are the responses that you give us. So that and also can be summarized using sentiment analysis. So determining the product reviews are positive or negative. Right? So some of the applications, there are many applications we're going to discuss now. Yeah. So could you please confirm my voice is clear to you? So I've received a message. Please confirm. Okay, thank you. Right. Now let's discuss about the overview of this text mining. So what are we going to learn as part of this module? So what is a text mining? Why it is relevant? Text mining is relevant. The application domains, complexity, and so these are the text processing methods, bag of words, and vector space model. So these things we are going to study as part of this module. What is the text mining? So the text mining is applying these computational methods and techniques, extract high quality information from the text. So when it's a high quality information, so the useful insights from the text. Okay, so I have huge number of views. Out of that, I want to extract the useful information that can be consumable readily by the business. Okay, so they cannot go and read each and every review. So that is not feasible option. Right? So we need to extract high quality information from the text by application of the computational as well as techniques. Okay. Why it is relevant? Why we have to study this text mining? So it is estimated that 80% of all the available data so is unstructured data. See, so far till yesterday, whatever the technique we have used, those techniques would be applied on the structured data. What is structured data? So as we discussed at the initial part of these sessions, any data that can fit in a tabular format like this. So any data that we fit into this tabular format like this, so this is a structured data. The unstructured data is so anything that you cannot fit into this kind of format, like the PPT that you are viewing here, the news articles that you read, the social media feed, Facebook posts, images, videos, and Twitter tweets, Instagram pictures, so YouTube videos, all these things comes under unstructured data. And the 20%, approximately 20% data is structured, and remaining 80% of data is unstructured data. That means there is a huge potential in this for this unstructured data analysis. Rich information will be available in this unstructured data, and if you don't analyze, we'll lose a big chunk of useful information. And that is the reason why we have to study this unstructured data or text mining also. And the unstructured data or text is present in various forms like books, financial and business reports, various kinds of business administrative documents, news articles, blog posts, wiki messages, all these things. So even the videos as well as images also comes under unstructured data. All right. So what are the application domains of text mining? So document classification. So what do you mean by document classification? Document classification is, let's say, we have websites. So in www domain, we have so thousands of websites. One website, let's say for example, so related to sports. So the other website, let's say related to education. So other one is entertainment. So a lot of other categories are there. So healthcare or medical web kind of a website, all those things. Now what I want to do is I want to classify all the websites that are there in this domain, okay, into these kind of categories. So many websites are there in this domain, right? Now, so I would apply the classification algorithm on this. Then I want to see whether this website comes under sports. So this website comes under education. This website comes under entertainment, right? So this is what actually document classification or website classification. So this is one of the application. And clustering, organizing the documents. So I can group them. So let's say there are hundreds of documents. I don't know what is there in this documents. So I can apply clustering algorithm on these hundreds of documents. Then I can categorize. So two clusters or three clusters. Hey, this is one cluster and this another cluster. So just read one or two documents from this cluster. Then I'll get to know, hey, this is related to sports. A lot of content is related to sports content, and I can say this is a sports cluster, and this is a lot of things are related to movies and the entertainment. I can say this is entertainment. So like that I can cluster the documents. Document summarization, as we discussed. So when you have the reviews, so I can summarize this review without reading the entire review. Okay. And visualization of the document space, we'll discuss that. And making predictions, so these are also very important, especially predicting stock market prices. Okay. So it is very important to analyze the news articles also. See what happens to predict the or to forecast the stock market prices. So I can take the values, the open price of the stock price, okay, the stock, and close price, open price and close price. And based on that, so I can build a model, forecast model, and using this I can forecast what would be the next day forecast value of the stock price. Now, so is it based on only the open and close price? No. So because there are a lot of factors involved, so to find out the forecast of the stock price. So there are a lot of dynamics are there in this. So geopolitical issues, the sentiments, the analyst reports, whether how many people are supporting that, all these things would come into picture. So all that information, where do we get? News. Also, the financial reports. Financial analysts, they'll publish the reports related to certain stocks, right? And also, so suddenly one government, okay, would be supporting of a company, or the governments, so opposed of the other companies, right? So these are the geopolitical scenarios which change day by day, and that information also we have to put into this model. Otherwise, this is a half-baked cake, right? So I can use the text mining and analyze all these news articles, analyst reports, and all those things, and this also I'll give it to my model as an input. And by make use of this numerical as well as the text information, this model would able to identify the pattern. Then we'll get the more accurate than a single model, a single input source like this. So that is also making predictions. We are going to use text mining and content based recommender system. Like, so if you're aware of this Quora, okay, a question and answers website, very very good website for the knowledge purpose. And if you read a particular content more often, so this Quora would give you similar kind of content more and more in your feed. That means based on the interest of the user, the Quora is recommending the similar kind of content. So that is content based recommender system. News articles or movies, books, or some other articles, right? So this is a content based recommender system, right? So these are all the applications. There are huge number of applications. So the text mining, okay. And again, the research is also going on is text mining, especially to find out sarcasm, right? For example, if you're writing a mail to our boss, so you sound some sarcasm in the mail, okay. So there's a mail, okay. So you're writing some content here, so you just include some sarcasm in this. But so that would create a lot of huge problem for you in the professional career, right? So the people are researching the moment you write some sarcasm, so the algorithm behind should detect, hey, so this is sarcasm, are you sure about this, so just thinking about it. So this kind of alerts should give by the software, by the algorithms. So this is where people are working heavily to identify the sarcasm, to find out the context of the information. So this is where people are doing more research. Right. Now let us understand the techniques involved in the text mining. So, or the unstructured text. Okay. So, in general, the interpretation or comprehension so of unstructured content like text, images, videos, this will be easy for us, but this is very very complex for the computer programs. Let's, for example, if I say that the number of cases are increasing in India. Okay. So if say, would you understand? Anyone? So the number of cases are increasing. So what I'm talking about? Exactly, right? Corona or crime cases. This is what actually, because we know the context. Because day by day, every day we are hearing something about the corona cases, and we are hearing that corona cases are increasing. And if I mention that, so day by day the cases are increasing. India means you are able to understand it's a crime related or it's corona related disease. But if I make this statement, if I send it to the computer program, the computer program does not understand what is this all about, because they do not have they don't have any context, any background information. We as a humans, we know that the context will be there because we'll remember that context, will have some background information, that information whatever we are speaking, right? So that is one challenge, big challenge, right? And also the text, whatever the text that we get from the social media or other websites, it's a full of ambiguous terms and phrases. Let's say for example, so generally we'll in English we'll write, are you fine? Okay, so this is what actually a proper English. Now, so if you see actually the short form messages or emails, if you are not close to them or in the Twitter, they'll write like this: are you fine? Okay, so this is what actually they'll write it. So how the hell the system would understand, program would understand what is this? This is basically like this. So first of all, for computer programs, the text understanding of text data itself is very difficult job, and that too we're making very difficult. Like, so this entire thing where this alphabet, R is alphabet, okay, U is alphabet, okay, FN doesn't have any meaning in the English dictionary. So these are basically full of ambiguous terms and phrases, and often strongly relies on context, background knowledge as discussed. Okay, and strongly based on common sense, knowledge, and reasoning, and also influenced by or influencing people's mutual interaction. For example, when you are speaking, when you are sending a text message, based on the level of association, level of relationship, you would start the conversation. So if it is your colleague, Okay, so you would start a conversation in a different level. You will greet them first, and then formally you will have a conversation. If that guy is your close friend, that conversation would be at a different level. Okay, you would start with hey, hi, all those things. You would start the conversation very informal way. You'll start that conversation. You'll have that. But it's family member. The relationship is a different, and there you don't see any formal greetings or anything. Just like that, casual conversation you have. That means based on the relationship that you share with the different people, the conversation levels would change, and based on that also the text would change. So all these things are very difficult for the computer programs to capture. Okay? So these are the complexities that are involved in processing the text. But even though these difficulties are there, still we are making a good progress in understanding text information. But there is a lot research to happen, a lot of better methods to identify, so that the models or the computers can understand the context, okay, the reasoning, the common sense. So when we have these things in the models, then we can say yes. So that is a good model. Even though whatever the thing that you speak, if it understand that, so that is a good model, a good program. You can say. Yeah, these are the additional challenges we'll discuss over a bit of time. Yeah, right. Now let us understand. So how do we process this text data? So whatever the data, when I say unstructured data, so be it the image data, be it a video data or the text data, the first focus is convert that into structured data. Let's see my unstructured data, for example. A lot of reviews are there like this. Okay, so a review is there. The primary goal of this text processing or the natural language processing is convert this into, okay, a structured form. Means give a structure to unstructured data. So like I have a column 1, column 2, column 3 like this. Okay, row 1, row 2. So this is structured data, right? Now we are going to discuss how we give a structure to unstructured data. What are the methods? And in the path of moving unstructured data to structured data, so what are the steps involved? So in this journey, so these things we are going to discuss now. So once we give structure to unstructured data like this, so once I get this, so I can apply whatever the methods I want to have. So we have machine learning algorithms, we have the deep learning methods I can apply on this. So this is very easy. Once you convert the data into structured format, yes, you can apply all the methods. So all the algorithms that we have discussed so far, as well as deep learning methods also we can apply. Okay, so this is one way. So this actually, even if you use any packages, the underlying mechanism is this only. So first they'll convert into the structured data like this, then they'll apply some other algorithms. So be it text data, be it image data. In fact, what is image data? So image is a bunch of numbers. It's a grid of numbers, rows and columns. That is straightforward the structured data only, right? So whatever the unstructured data that we talk about, so that first has to be converted into structured data like this. Then we can apply any of the methods. Some of the packages, okay, would directly convert the structured to unstructured. We don't get to know these things, and we'll get the output. Okay. We are going to understand this underlying mechanism of how do we convert this unstructured to structured data. So that's what we are focusing as part of this module. Okay. The first method to give unstructured data to structured data, the bag of words or BOW, representation of the text. So this is a first method to impose a structure onto unstructured data. So as part of bag of words method, so let us see how do we, yeah, let's see how do we give a structure to the website, which is a very simple method. So this is a website. And what we do is I'll take all the unique words from this website. So I'll arrange in the column 1. And I'll see how many number of times those words have occurred. So that is number of times, number of occurrences or frequency. So this about has occurred 2 times, all has occurred 2 times, Africa has occurred 1 time, like that. So I'll arrange all these words into this column, unique words, and I'll see the frequency of those words occurred in this website. So this is one method, very simple, very easy method. That's a bag of words representation of the text. Okay. Yeah. So the most popular method is vector space model or VSM. Okay. So this VSM method is a generalization of the bag of words. So whatever we have discussed, so this VSM is a more generic method than the bag of words. So just pay attention here. We are going to discuss about something important. Based on that only, the next 1 hour lecture would be depends on. So in this VSM, each document from the corpus is represented as multi-dimensional vector. Okay. So few terms. Corpus. What is a corpus? The corpus is collection of documents, collection of records. Let's say I'm processing reviews. Okay, this is review 1. So this is review 2, review 3, like that, review 100. So when I combine all of them, so review 1000, all those reviews together, then this is called as corpus. Corpus. Okay, so I'm analyzing documents. Okay, A4 size documents. First document, second document, third document. Combine them all of the documents, thousands of documents. Collectively together, we refer as corpus. So I'm analyzing messages, SMS, first message, second message, third message. Combine them, collectively we'll refer as corpus. So whatever the text, okay, you have a book, entire book is there. Book 1, book 2, book 3. Analyzing all these books. So collectively we refer this as corpus. That means corpus is a collection of documents, collection of reviews, messages, or books, whatever it is. If we put together all of them, then that is called as corpus. Okay. Now, so each document. So let's say in my corpus, so I have 100 documents. So this one document, second document, okay, is represented as multi-dimensional vector. What's a vector? So vector will have direction and magnitude, right? So I can say 2 comma 3, so I can represent this as a vector space, so like this. So this is a direction, there is a magnitude, I can find out that. Now each document I can represent as a multi-dimensional vector. So that is basically one dimension means one column. That's what we understood, right, from PCA. One dimension is one column, and here multi-dimension means multi columns, like this. So here I'll have document 1. So this document 1 I would represent as multi-dimensional vector. So this is a dimension 1. So this is a dimension 2. So like this, dimension n. So likewise, I'll have all these documents, I'll represent like this. So this vector, the values are nothing but here I can say these are the vector, right? So one row is a vector because so each dimension will have one value, and in this, so n dimension have the vector, n dimensional vector space here. Now, so each unique term from the corpus represents one dimension of the vector space. So how do we define these dimensions for this vector space? So I'll collect all the unique terms from this, all the documents. Let's say out of 100, so 100 documents, there are so 1000 unique terms. So 1000 unique terms are there. So I'll have 1000 dimensions like this. So the dimensionality of the vector space is depends on the number of unit terms of the documents in the corpus. For example, let me take a simple example here itself. This is my corpus. Just understand. For example, just assume that this is my corpus. 2 reviews are there. What I would do is I'll take unique terms in this corpus. This is one unique term. This is another. So this is another. This is another. This is another. What? So this is not a unique term. What is there? So 1, 2, 3, 4, 5. 5 unique terms for first sentence. Okay. 6, 7. Okay. 8, 9, 10, 11, 12. So for this corpus, so the dimensions are 12. So I'll have 12 columns. So that is the dimension for the vector space. So term can be single word or sequence of words. I can define term can be single word or sequence of words also. The number of unit terms in the corpus determines the dimensions of the vector space. So that's what we have discussed. Right? Now, what are these dimensions? Simply, I'll mention the unit terms here. The unit term is term here. This is the first review. So then can is the second one. Third one is single. Fourth one is word. So like that, each unit term in the corpus would act as a dimension in the corpus or in the vector space. And then I'll take the each review. So I'll see that. Okay. So whether this review, this review will have how many values for this term, for this cane, for this single, like that. I'll fill this matrix. So this gives us the idea of how to convert the unstructured data to structured data. Okay, so this is basically VSM. So let me repeat quickly. The VSM enables us to convert the unstructured data to structured data. Okay, so it has got a defined methodology. So in this, each document in the corpus is collection of pool of all the documents represented as multi-dimensional vector. Each document, each review, each message would be represented as multi-dimensional vector like this. And what are these dimensions? The unique terms from the corpus will take and will mention as a dimensions. Okay, and we'll see how to fill these values. So we have to fill these values, right? So we'll discuss that. But this is the wireframe. You can think of a framework for the converting unstructured data to structured data. Okay. So for example, so we have 5 documents. So document 1, so document 2, 3, 4, and 5. So the dimensions, okay. So here other way around. So here on the columns we have mentioned as documents, document 1, 2, 3, 4, 5. What I would do is I'll take the unique terms from all of these 5 documents. So I'll mention on these rows. Then I'll check how many number of times the word complexity has occurred in the document 1, 2 times. The word complexity has occurred document 2, 0 times. Document 3. So like that, I'll find out the frequencies of these words corresponding documents. I'll fill this matrix. And then I'll transpose this matrix. When I transpose, so I'll get this. So this is a word 1, the complexity, word 2, word 3, like this. And then this is a first document, document 1, document 2, so document 3. Now you see, so here I'll have a 2, okay. So this is 0 or whatever is the values. Now this document, the first document, so we have represented as a multi-dimensional vector. Second document we have represented as multi-dimensional vector, and each term here is a unique term, and this number of unique terms in the entire document set, that is corpus, so would be the dimensionality of this entire matrix. Okay? So this I will transpose, then I'll get this matrix, and the representation of this is called as term document matrix, and this one is called as document term matrix, in short DTM. In the rows, if you have the documents, then that is called as a document term matrix. In the rows, if you have the words or terms, then that is called as term document matrix. Right. So this is fine. So that means we have given the unstructured data, text data to a structured form. So once we have this, so this is as good as our tabular structure, right? The structured data. So whatever the CSV or Excel sheet that we have been referring to or using in the algorithms. So this is similar to that, right? So these are row 1, row 2, and column 1, column 2. Then we can apply whatever the algorithm that we want to apply. So since we have the numbers only in this, and we can treat each one as a dimension, and we can go ahead and apply. But one problem here is the dimensionality. Okay. So if you are referring, for example, any corpus, lakhs of reviews, okay, lakhs of reviews, how many unit terms would be there? Definitely, even if you take one unit term for one review, 1 lakh unique words, 1 lakh unique word. right? So that means 1 lakh columns will be there. So that is one downside of this VSM. We have more sophisticated methods, so what to wake and what embeddings, so those would reduce the dimensions. But this is a popular and the old technique, I would say. So still people are using for the converting the documents, the unstructured data to structured data. Okay, so that is another information. The other thing is, right, so once we have this, let's say once we build this TDM or DTM, so how do we give this? Should we go for the frequencies, or should we have some other method to find out the values in this matrix, this cells? So whatever we have implemented is, that is called as frequency method. So we also have different methods, okay, inverse document frequency and other things, okay? So that we'll discuss. That is one thing. And also before going for this TTM or DTM, what we do is we'll have to process this text information, okay, because the text will have lot of ambiguous words as well as lot of the a is and all these things are there. So this you don't see here, right? That means this data has been processed before going for TDM or DTM, and that is called as text pre-processing techniques. The text pre-processing techniques we would apply, then after that we'll go for the DTM or TDM. On the clean data only we have to apply DTM. So otherwise, so we'll get a different the DTM matrix, the frequency would be distributed differently. We'll discuss that after the break. So but just understand that before going for DTM or TDM, we'll have to apply something called as text pre-processing methods. So that we'll discuss. Okay. So there are 5 text pre-processing methods are there, and that we'll discuss after the break. Okay. Yeah, hello all. Let's continue our discussion. Right. So we were discussing about the data processing or text processing methods. So let us understand why do we have to process the text before going for DTM or TDM. So we said, right, so before going for this TDM or DTM, we have to process this text. So that is called as text pre-processing methods. Then only we'll go for this one. So let us understand the need for text pre-processing. So these are the methods that will apply. So normalizing the text, removing and with a very small high frequency stop words, and the lemmatization. So let us spend on these steps. Let us discuss these steps one by one. The first one is normalization of the text. This is the first method or first technique that we will apply on the text pre-processing. Let's say, for example, I have these words. So apple, apple, and apple. So when we start a sentence or a paragraph, so we would tend to use a capital letter as a first one. So that's a grammar rule, right? So apple. And if you have to use apple in the middle of the sentence, then you use all small letters. And if someone is angry, so they'll use all capital letters, apple. Now let's say, for example, if I don't read, what happens? So if I don't read this data, so I'll have apple here, because for system, for computer, so this apple is different, this apple is different, this apple is different. And as we discussed, all the unit terms from the corpus would define the dimensionality of the vector space or TDM. And when you mention like this, your dimensionality is going like anything, it grows. And also in a document one, first document, so the real frequency in this first document apple has occurred, let's say, 5 times, out of which it divides this 5 frequency into these 3 dimensions. The capital A apple has occurred 1 time, this has occurred, let's say, 3 times, and this has occurred 1 time. That means the frequency has been distributed, so for these 3 words. But for us, apple is apple. Okay, the frequency should be 5. But for machines, if you mention like this, the capital A, small letters, capital, all the capital letters, these are different for them. So how these are different? Because first, how the machines would store these alphabets, the strings. So first, it will convert them into ASCII format. Okay, ASCII format. For capital A, I think that would be 65 value. Capital A value is 65 and small a value is 95 something. So like that, we'll have the values for each of the alphabets. Different values will be there for capital and different values will be there for small letters, and this one would be converted into binary values, binary format. Those values would get stored. Okay, let me show you this. Right, so if you see this ASCII values for small a 97, and how do we represent that? So this is the binary format. Capital A ASCII values are 65, and this is how actually the binary values. So these values would get stored, and as the binary values are different for this capital A and small a and capital A, then the systems or computers would treat them as different. So unless you treat them appropriately, right? Right. So so in that case, if you don't treat, the machines would consider these words as a different words. This apple and this apple and this apple. But as we know, these are same words. So we want to make system understand that hey, these are not different words, these are same words only. So to make sure that these words are same, what we do is we'll convert them into a single case. So either uppercase or lowercase. Okay, so we'll convert them into all lowercase. So this is one of the technique, the text pre-processing methods. So that is called as normalizing the text. Also, if you have, for example, intelligent systems or intelligent system. Excuse me, just give me a minute. I'll change the room. All right. So we will change so these cases into smaller case or uppercase, so that the machine would understand. Yeah, this is only one word. Then the frequency will not be distributed. So when we uh, change it to one word, the smaller case or uppercase, then I'll have only one dimension, that is apple. Okay, and the document here I'll have the frequency as 5. So the frequency will not get distributed, okay, because only we have only one apple here with one case. So this is one method. The others are basically if you have intelligent systems. So all, so I is capital and S is capital. And intelligent systems, so S is small. Intelligent hyphen systems. If you don't treat them, so uh, in our DTM or TDM, so each one will occupy so one dimension. So here intelligent system with a capital I and S. So this is intelligent systems like this. That means the dimensionality would be increased. So this also will process will make like this intelligent systems. Okay. Right. So this is basically called as normalizing the data. The next method is removing high and low frequency text. Okay. Yeah. See, for example, and sometimes out of so 100,000 reviews, so all the reviews are negative reviews. People are scolding like anything, and there is only one review. So they mentioned about very good. Okay, very good. So only one review out of those many. So this is only the frequency is very very low, and so probably that guy so might have mistakenly given this kind of word or this kind of review. All the people are scolding, but only one guy has given a good review. So in that case, so definitely we can say that the product or service is not good. And this only one frequency word will not add any value, any it doesn't give us any information, right? So this low frequency words will remove, and also high frequency words. So in English literature, so A, the articles, right? A, the, and auxiliary words. So am, is, are, the. Okay. So these tend to are, okay, were. These tend to occur more times. These are all high frequency words in any of the reviews or in any of the text if you talk about. And these also does not give us much information about the review, about the opinion of the writer. So this also have to be removed. So these are all the high frequency words, and there are certain terms so which would occur very low frequency. So those two things we have to remove from the corpus, from the data, right? So that we can decrease the dimensionality of the DTM or TDM. And one method to identify this low frequency and high frequency words using GIF's law or GIF's rule. So what it states is, so if you arrange, all the words in the English literature, okay, like A, D, okay, and like this, all the words, the high frequency words would be given rank 1, the low frequency words will be given very high rank. So for example, that distribution follows this. Okay, so if I distribute based on the rank and based on the occurrence, based on the frequency, okay, the frequency is very high. Okay, and if I see the distribution of the rank versus the frequency, so that distribution follows like this. So this is called as GIF's law or GIF's distribution. For example, these are rank on x-axis, and y-axis we have frequency. And this is highly frequently occurred word, the rank is 1, and this is next, probably this might be A, this might be D, and like that. Okay, and this is very low frequently occurred word, and you see this is only frequency is 1, and the rank is very high for them. And what we do is, so we'll go for like this. So we'll remove these high frequency words and low frequency words, and these words, the intermediate words, will use for the analysis. So this gives us the more information. That means most of the people are, okay, most of the people are using these words, which are not again these kind of words, and which are not with low frequency also. These tend to give us a good understanding of the review. Okay. Right. So what kind of the words, the high frequent words, the A and B, do, to, these are the basically high frequency words. And the low frequency words like this, so core domain words like the dextrosinistral, probably medical term or something, right? So this, if it occurs only one time, then we don't have to care about it. Okay, so this doesn't give us much information about the opinion. Right. So stop words. We also remove stop words from the reviews. Let's say, for example, this is one of the sentences. So this is not a good option. Okay, so this will not give us much information. Is also not give us much information. A also does not give us much information. These three will be removed, and of course, so we can also remove not and good. But if you want to retain that, not also gives us some information. Good, yes, option. Output of this, I'll get option, good, okay, and not. So these three will be removed. And if you talk about this to be or not to be, okay, so if I apply stop word mechanism on this, so nothing I'll get. So this also will not get anything. Be or not to be. So all these things have to remove. So nothing I'll get. So it is estimated that 20 to 30% of the words, okay, so are stop words in any corpus. That means just those have to be removed from the analysis. So these are the stop word elimination. So then the final one is lemmatization or stemming. Okay, lemmatization or stemming. This is, for example, when we have multiple words, the different parts of speech, like the different past tense, present tense, or past participle, like argue, argued, argues, arguing. If I don't treat, again the problem of normalization would come into picture. So the DTM would allocate one dimension for this, one dimension for this, and this. 4 dimensions will be there. And it is not that, so all these are different words, right? So argue, so it's the same meaning. So even though that is argued, the tense is different, but the meaning is same, right? So we have to again normalize this data. So normalizing this different tenses is called as stemming or lemmatization. And in the stemming method, so what we do is, this stemming method is basically a crude method, in the sense it checks for the letters are common characters. So in all of these words, only those common characters would be retained. Other letters would be chopped off, would be removed. If you see ARGU, 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 only this ARGU is repeating. Only that will be taken, and other things just removed like this. Okay, but do you get the meaning of this argue with this word? No. So this argue, argu, we don't have any meaning for this. So I wanted to convey this argue, but this kind of meaning I'm not going to get from this word. So this is called as stemming, but this is not the efficient method. So we have some other method called as lemmatization. What is lemmatization is, it checks for so all these words and it convert them into root word. So argued root word is argue, argues, argue, arguing, argue. Right? So all the words would be converted to a root word where we have a meaning, dictionary meaning. So that's what the lemmatization does. So this also reduces the dimensionality of the DTM. Right? So these are the steps we would apply. Like normalization is one method. Okay, remove stop words, remove high and low frequency words, then lemmatization. So these are the four methods would apply for text processing. Okay. So once we apply this, then we'll get the cleaned text information. Then we would go for the DTM or TDM on that. All right. So I have the text here. So I will apply those four steps, 1, 2, 3, 4, the text processing methods on the text information. Okay. So then I'll get the clean data. So that clean data, then I'll go for the DTM or TDM. Let's say we are going for DTM, documents are on the rows, document 2, document 3. Then this is my word. Now, what we're going to discuss now is how are we going to fill this matrix? So are we going to fill this matrix just the frequency, how many number of times this word has occurred in this document? 5, 3, 2. Yes, so this is one of the method, but we are going to discuss other methods also. These are the methods, 4 methods on how to fill this matrix. Is it just simple frequency or binary or something else? Right? So that is what we are going to discuss. So once we fill this matrix, then our job is done. We have successfully converted the unstructured data to structured data. Right? Okay. So the first method is a binary weights. So that is the first method. We have binary weights, a turn frequency, inverse document frequency, TF-IDF. These methods will use to fill the matrix. Okay, so then that completes the TDM or DTM. Okay. So in this case, the binary weights. So as the name suggests, binary means 0 or 1, yes or no. Okay. Similarly, we have, let's say these are the 3 documents. Let's assume this is a corpus. Okay. And we'll take the unique words from this corpus. I'll mention on these columns. So dimensions. From the document 1, so the text is there in the document 1. Yes, it is there. If it is there, then put 1, otherwise 0. So it doesn't come into picture the frequency. No matter what, how many number of times the text is there in the document 1. So I'll mention only once. So information is there. Yes, one time. Identify is there. So mind is not there. So that is 0. Right. So that means whether a word has occurred in a document or not. That's all. That's the binary weight. If it occurs, put yes. Otherwise, put 0. Let's say, for example, document 3. Text is there? No. So it's not there, 0. Information, no. Only apple is there. So apple, yes, 1. Delicious is there, 1. So this method is called as binary weights method. Yes or no, 0 or 1. Then the next one is turn frequency, TF. So TF of a term T would be computed using this formula, count of the term in the document. So let's say, for example, this is my document. So lot of text is there, and I want to find out the turn frequency of a term called good. So this, I want to find out turn frequency for this. So what we do is simply how many number of times this good has occurred in this document. So that is what the turn frequency is. So in this, turn frequency of good is equal to the count of the term is good here. So in this document 5. Okay, so let's say there are 10 times. So the good has occurred in this document 5. So that is 10. So this is another method. So it's simple frequency. So that is called as TFR, turn frequency method. Then the next method is so inverse document frequency. So while the turn frequency would be computed at document level, so at document level, okay, so the IDF would be computed at corpus level. So let us see how do we compute that. Let's say, so I have a corpus. In this, I have 100 documents. So document 1, document 2, like this. Now again, I want to compute IDF for a term called good. Okay. So IDF of good. Okay. So this will give me the formula log of, so n is number of documents in the corpus. How many number of documents are there in the corpus? So we have 100 documents. So n is 100 by, so df of t. Df of t is number of documents with term t. Out of this 100, how many documents has the word good? Okay, so let's say there are 10 documents. In those 10 documents, the word is good is there. Okay, so this one document, this second document, like that. So we have 10 documents, the word good is there in those documents. So 100 by 10. So this is IDF of the word good. Okay, so this is another method so we can use. Okay, let me repeat. So IDF, inverse document frequency of a term, is so 1 plus log of how many number of documents are there in the corpus. Okay, out of 100 there are 10 documents, the word good is there, that is 10. So this gives me IDF of good. Then so TF IDF. So this TF IDF, turn frequency IDF inverse matrix. So we can use turn frequency or binary or TF IDF, right? So let's say we are going with turn frequency. So this 5, so this 7, this is 0, like that. That means in the document 1, word 1 has occurred 5 times, 7 times word 2 has occurred, 0 times word 3. So like that we'll fill this matrix. Then we have given a proper structure to the unstructured data. And the dimensions are nothing but the unit terms in the corpus. So that is the dimension of this document term matrix, right? Right. Now, so let us discuss one use case using this VSA method or in the text mining method. For example, I have this DTM or TDM. I want to find out the document similarity or clustering of the documents. Okay. So this is a word 1, word 2, word 3, word 4. Or I want to find out, or I want to cluster all the reviews into positive and negative. So let's say I have 1 lakh reviews from the customers, and I want to classify or cluster all these 1 lakh reviews into positive reviews and negative reviews. Okay, so then I can count how many number of reviews are positive and how many number of reviews are negative. So without reading all of them, I want to do that automatically using text mining algorithm. Then I can apply first this, I can build this DTM or TDM. Then, so each document will have the numbers, right? So these numbers, so I can apply something called as cosine similarity. Okay, the cosine similarity is basically finds out the similarity between the two vectors. The cosine similarity is the dot product of two vectors Okay, the length of the normalization of the vectors. So this gives us the angle vectors, the cosine similarity. Okay, if the angle is very low, if the angle is zero, those two vectors are overlapping. If the angle is huge, those vectors are not similar. For example, if I find the cosine similarity, the value. So here, let's say 1. Okay, cos theta is 1, theta is cos inverse of 1. Right? So when do we get cos value as 1? So when I have theta 90 degrees. So the angle between the two vectors is 90 degrees, then I'll get the cos theta 1. Then if this is 0, okay, cos 0. So the theta, this is 0, cos 0 is 1, right? Other way around. So cos 0 is 1. So if the angle, okay, angle between the two vectors is 0, okay, then I'll get the 1, the cosine value here. Cos 90 is 0. That means if the angle between the two vectors is 90 degrees, then I'll get the value, the cosine similarity value as 0. Okay. So based on this, we will find out. Let's say, for example, this is 1, 2, 3, 4. Okay. So this is 0, 1, 3, 4. I'll take these two documents. Okay, two documents. I'll apply on this cosine similarity. So the vector A is document 1, vector B is document 2. Then I'll find out this. Let's say, for example, the cosine similarity value. The value is 0. So when do I get the value cos value 0? When the angle between the two vectors, document 1, document 2, is 90 degrees. 90 degrees. The similarity is 0. That you can understand, the similarity is 0. The vectors are like this. So document 1 is this side, and document 2 is, so there is no similarity. Let's say the value is 1. The value is 1. So that means the angle between these two vectors is 0. That means they are overlapping vectors. So this is document 1 and this is document 2. So any value, the cos value is near to 1, you can think of they are similar. The value is near to 0, they are not similar. So based on this cosine similarity, I can find out the similar records in this the term document matrix. And when I build the cluster, so only two clusters I'll go for, only two clusters, right? So when I say only two clusters, the similar the records would go into this, and similar documents would go into this. Okay, so one is a positive cluster, the other is negative cluster. So that's how I can find out the positive and negative reviews using this cosine similarity after converting the data into structured format. Right. So this is same as, yeah, this is the cosine similarity between the two vectors v and vj. Okay. So here the angle between the two vectors. So this is a vi. You can say this is a vj, and is low. Angle is low. Then they are similar. The angle is very high. Unrelated scores and opposite scores means the angle is, the vectors are very opposite. The documents are very non-similar documents. We can understand like that. All right. Now what we are going to do is, yes, so we have understood some concepts related to text mining, how to process the data and how to find out the similarity between the documents or similarity between the reviews. Now, where do we get the data? So how do we get the data? The text data. Now we are going to extract the text data from a website, Amazon. Okay. So from this Amazon website, we are going to extract the reviews. And on those reviews, we are going to apply. So all these methods, whatever we discussed today. Okay. The first step is we are going to extract the review data from this Amazon for a product, and then we'll apply all the text mining methods, and we'll go for something called as word cloud, which is useful for us to understand what is this text all about. So this process we are going to follow now. Right. So I'm going to extract the reviews from this website. Let me show you. Amazon for this product. Okay. So it's Apple MacBook Air. So these are the reviews. Right. So this is a review. So it's amazing. Battery lasts around 10 to 12 hours. Best laptop for students and coders. So finally, a MacBook position. Yeah, these are the reviews I want to extract. So how many reviews? So I want to extract for at least 10 pages. So these are the reviews here. I want to go for next page here, and here also I want to extract all of them. So like that. So next 10 pages. 10 pages reviews I want to extract. How many number of pages you want to? You can extract that. Okay, right. Now let me explain you the code here. For that, we need these three libraries: RWest, XML to understand the XML page structure of the Amazon, and MagReadR. So these three libraries we need. Okay. So this is the website, and for I in 1 to 10. So this for loop is basically iterate over all the pages. So one means I equal to 1 means first page, I equal to 2 means second page. Okay, so like that 10 pages information we need. Read underscore HTML, so is a function. We are pasting the URL. Okay, this is Amazon URL, so that we have stored in this object or variable. That URL we are pasting, and coupled with I means what? The number of page number. Okay, every time when it iterates, the new value would be given to I. First time I equal to 1. Okay, then separate equal to this equal to. What does it mean? This means this URL does not change even if you change the page, only this I value changes. Let me show you that. What does that mean? You see, we are in second page, the page number 2. Now if I go to page next page, okay, only this changes, entire the URL would not change. Let me go to third page here. It's page number 3. That means this URL remains same, that is static, only the page number would change. So that is what actually we are giving here. URL does not change every time, so the I value changes every time when we loop the next time, next page. And what is the separator between URL and this page number? That is equal to. Okay, so that you can see here. So the separator between the page number and this uh, the static URL and the page number, that is equal to. So that is what we have given here. Then, so what is it has to do? Let's say, for example, it went to first page, okay, and it has to find out the HTML node, that means HTML page structure. Then, so it has to locate this keyword, and after this keyword, we will have the real text or real review. So whatever the information is there after this keyword, then pull that information. Okay, let me show you. So this is HTML page structure. Yeah. So review hyphen text. The review given by the users is available only after this keyword. So everywhere. So just check for this keyword, and then whatever the text is available, just pull that. That is what we have mentioned in the code. The next, for example, if I see next, this is under review. So it worked only for 1 year. After 1 year, so it stopped working, something like that. So this text is available only after this review hyphen text. These are next review. So checks for, so all these keywords and whatever the information is available, so that will be pulled. That is what actually we wanted as part of the review analysis, right? So HTML node, check for this node, review hypertext, and whatever the information is there, pull that HTML text information, save that in this URL, now this variable review. Okay? And in one page, whatever the information is there, pull that, so that will be available in a review. And for all the pages, save that in this. For all the pages, save that review information in this Amazon underscore reviews. So this is what actually the R code is. Right? Yeah. So this is kind of web scraping. Yes, that's right. Let me demonstrate this to you. So length of this is okay 100. Then let me write it to a TXT format. So Amazon reviews, and write it to the TXT format. Yeah. Okay. Let me show you this. So this has been saved. Yeah. And where is that? Text mining Amazon reviews. Okay. Right. So this is Amazon reviews. Right. So I pulled .txt today 12:43 p.m. This is what actually got saved now. Right. So let me open this. So this is the first review, second review, third review, like that. So we have 100 reviews. So now we have got the data. What is the next step? So apply the text mining, apply all the processing methods, and identify the reviews. Okay? Let us do that now. Now we are going to apply all the steps that we have discussed so far. So we need these libraries, text mining, so Snowball, Word Cloud, all of them. Right. So what are the reviews that we have extracted? So we are going to convert them into character. Then apply the transformation UTF-8, because when you scrape the data from the websites, that comes with various symbols and all those things, right? So R does not understand all of those symbols. We are converting them into one uniform, a Unicode transformation format 8. So it is always best practice to convert the text data into one of the transformation formats. Okay, so then that is done. So here we are building the vector source, the corpus. That means we are collecting all of them, we are pulling them into a corpus. Now let us see the output of the corpus. Yeah, here's a corpus, all the reviews together. So okay, so you have been seeing people so and so, there is a review, right? Now, so tm underscore map ex is what the review data is available, and to lower means we are converting all of these the letters into lowercase small case. So that's what it does, right? Let us see that. Now you can check. So all the letters have been converted into lowercase. So earlier we have seen this OK, O is a capital, so is also capital. Everything convert to smaller case now. Then remove the numbers. So numbers sometimes are not necessary for us. Remove the numbers. Then remove punctuations. Certain punctuations will be there, that also I want to remove. Now remove stop words. We discussed A and the all those things. I want to remove them. And there are certain terms so which would occur with very high frequency, since this is related to Apple MacBook, right? So people tend to use Apple more and more, so that is not required for us to get the pulse of the customers, right? Now let us see the data here. So we have cleaned the data, and you see the unusual spacing between the words, right? So here the space is more than one. So this also space is more than one because we have removed the stop words. So that stop word created a space in the sentences. Now let us adjust this. Let us remove this extra white space. So this is remove the extra white space. Yeah. Now you can see the extra white space has been removed. Now let us build the term document matrix TDM. So this is on this columns we have the documents, and rows we have terms. So able. So in document one, so one time it has occurred. So two, zero times, like that. So this word Air, MacBook Air, right? So Air has occurred 18 times. So in the ninth review. Okay. So like that, how many we have? Total 100 reviews are there. And first few words, the count we can see. This is called as so term document matrix. Now let us find the frequency of these terms. So these words have occurred highest number of times. Laptop, MacBook, it's good 51 times, right? So product 44, Windows, service, buy. So these are the words so which have occurred highest number of times. Now let us see this. Let us go for bar plot with highest words. Right, so Air has occurred this many times. Okay, so MacBook, so get. So these are the word frequencies. So if you see any negative word which has occurred more number of times, so you can just take out that and you can understand more context about that. Let's say for example, the people have used battery. Okay, so 38 times. So I want to understand in what context the people have used this battery. So I'll go to that document. So search with battery. So I'll search with the battery in the main review. These are one of the methods to get more context. Okay. So people have used battery. It's amazing. So here you can see the second review. It's amazing battery lasts around. So these are positive context people have used. And here this is another word, good battery life. Good. So it's also positive. And this is where actually just go through that particular review where the battery is mentioned like this. Then you can understand whether the people are using this in the good context or bad context. So like that I can find out some more context about that battery. Okay. This is one way. So since the Apple Air laptop, these are occurring very with very high frequency, right? So I want to remove those because those will not give any the emotion or positive or negative. Okay, so I'll remove those things. These are, we can remove the Apple these things. Then so when you remove these words again, they'll create some extra space, white space. So remove that white space also. Then build the TDM or DTM. Right, now we are going to build the word clouds. Right, so these are the word clouds. That means based on the occurrence of the words in the reviews, the font size would be defined. The higher font size indicates that many people have used these words. The battery have been used by many people. Service, the quality, warranty, Windows, like, okay, and working now, best. So these are the words people have used mostly. So this is a word cloud. Okay. Now I want to distinguish the positive words and the negative words. So this is combining all the words, right? Positive as well as the negative words. Okay. This does not give me much information. So I want to separate the positive words aside and negative word aside. Now let us do that. For that, what we do is, so we have a list of positive words and list of negative words. Let me show you that. So we have approved list of positive words. So abounds, abundance, so abundant. So these are the list of positive words. What we do is we'll compare our words from the Amazon review with these words. If it matches, then we'll say that is a positive word, and we'll store that in a different data frame, a different variable. And similarly, we have negative words list also. Right? So edict, okay, adamant. So these are the negative words. So similarly, again, we'll compare these words list with our review words list. If it matches, then I'll save that in a different variable. Okay? That is what we are going to do now. Right. So I've loaded the data. Now let us go for the positive words. So I'll match the words which we have uploaded with our the Amazon review words. And this is a positive word. It is so small. Okay. So here we can see good. These are the positive reviews words. Excellent. So properly, works perfect. Okay, comfortable, responsive. So benefits. So these are the positive words. Okay. Now let us see what kind of the negative words. So these are the negative words: confused, fragile, disappointed, unable, issue, problem, corrosion, short, okay, expensive. These are the problems the people are facing. Now, what we can do? Yes. So the highest problem is issue. Okay. So many people have used this. Then problem. I'll take out these words. I'll check for reviews where these issues have been arised. Then I'll get more context. That will be useful for the the company, they can upgrade or they can work on those products, and they can release them in the next version, the better product, which does not, right? So these are, we can understand the customer pulse using the text mining. Okay, so there are some questions. Yeah, I'll answer those questions. Just give me a minute. Right. So that is okay. And whatever we have seen, this is actually called as unigrams. Okay, these are called as unigrams. When I say unigrams, single word at a time. So they'll find out the frequencies and they'll go for that. They are called as bigrams. So what are they? For example, uh, battery not working properly. Okay, so this is a statement. So if I go for unigram, what happens? Working will, right? So that is a positive, but the intention is not working properly. So for this, what we use, what we do is we will combine them. I will consider not underscore working as one word. The sequence of the words will combine them. When I say bigram, then working properly as another one, like this. So now I'll get the context, not working. So when I see this word, yes, so thing is not working properly. So this is called as bigrams. And we also have trigrams. Trigrams, three words together, so we will compute the frequency. If many people are using these three words together, then the frequency would go up, then that would show up here. So that's how actually we can find out or get the more context so about this, the word clouds. But as we increase the number of grams, right, so trigrams and 4 grams, like that, the frequency would tend to go down, so we may not get the exact things, but generally we'll go for unigrams and bigrams, so this is sufficient to go for, right? Then we can also find out the association between the words. For example, I want to find out, so what are the other words that are strongly associated with a word called battery. Okay, so what are the other words people are using with battery, that I want to find out. So with battery, people are using hours. They are saying that best battery, the lifetime, that means lifetime is high or low, male or processor, range, the battery life, the better, the pro, backup, brightness. Even they increase the brightness, the battery is also long. It comes, many hours. That's what, right? So these are the words that are people are using in association with the battery. Okay, let's say let us go for the words. Worst agents, follow-ups, okay, provide, purchasing, satisfaction. People are using these words, worst word with these words very often. Right? So this, based on this, you can understand the different words. For example, so issue, right? So here is the issue. So you can also understand with this issue what are the other words people are using. Issue, writing, review, final, Wi-Fi issue, okay, in the laptops, okay, and boss, okay, boot is another issue, cooling is issue, okay, so dusted, distributed, detected some issue. So hardcore GBs, some kind of problems they are using in conjunction with this issue, speaker issue. Okay, solved, some issue has been solved. Right. So this information we will get the high level. Then with this context, again go back to the reviews. Then we can uh, get more and more context about that issue, so that we can solve those problems in the next version or for that customer. Right. So this is what the text mining, some portion of the text mining in the text mining module. Okay. Now, so tomorrow what we are going to discuss is again text mining only. We are going to discuss how do we use the text mining to classify text data. Let's say for example, so I have messages, okay, or we have um, in a website we have reviews, like Amazon website we have reviews, all the reviews are there, right? And with those reviews we can build an algorithm whether there is a positive review or negative review. So this is my model. The model throws out whether the review is a positive or that is a negative. Okay, on daily basis, let's say on daily basis, so in the website there are hundreds of reviews are there. Then these reviews, so I'll feed it to my model would say that okay, out of these 100 reviews, so 70 reviews are positive reviews and 30 reviews are negative reviews. And this automatically finding out the reviews are negative or positive, and that model, so we are going to build tomorrow, and we'll build that in a SMS, the messages, whether the messages is a good message or it's a spam message. So for that we'll build, and the application is similar. Once we build the model, the classification, you can feed the data, be it a text or whatever it is, the model will work on that and throws out whether that's a positive or negative or class 1 or class 2. So this one thing we are going to discuss tomorrow. And the next one is how to extract the data from Twitter. We'll see that. Twitter data extraction. Second thing, and third thing is emotion mining. So emotion mining is a third topic we are going to discuss tomorrow. Okay. So this is the agenda for tomorrow, and that concludes our the text mining module. Right. So all right. So that's all for today. Okay. Questions. Okay, there are a few questions. So for assignments, please contact our assignment support team, Mukesh and Tarun. They are also part of these sessions. Please contact them. If the word does not match with the existing word list, then we have to add them. So that is a live document, running document, whatever the positive and negative word list, right? So we have to keep on updating that. So then we'll get the good match. If it doesn't match, then that will not be picked up. So what are the list that we have here? So if any word from the review does not match with these two lists, positive or negative, then that will not be picked up into the review analysis. So I have no issue. So is it a positive or no? It is a positive basically. So the issue is a negative. So in that case, we should go for bigram. That means no and issue would be tagged together. Then we'll understand the more context about that. So n-grams, so a lot of documentation is available for computation of n-grams, so bigrams, trigrams. So just you have to modify a little bit in the code. The process is same. In case of word cloud, so you'll have to go for bigrams. That's all. Right. In bigrams. So not good means bigrams. Yeah. Right. Correlation limit to 0.3 is whatever the association that we are finding out. So that is based on the correlation. Okay, so the correlation between the issue and the other words is at least zero point 0.3, then only we want to see that. Yeah, web crawling is extracting the data from the websites. Okay, right. That's a web crawling or web scraping. So what's like, okay, so this does not consider, okay, this is what actually we have discussed, the complexity in the phrases, in the complexity in the words. Awesome, right? So people tend to write all these things, so this will be removed. Yeah, we can understand, but machines would not understand that. Yeah. So day 11 recorded video is not available. Yes, we'll check that. So Anvesh, please check in, look into that. Okay. So all right. So thank you. Thanks for joining for today, and we'll meet tomorrow, and we'll complete the text money module. Okay. Thank you very much. So the jargons, different phrases tend to change. Right? There would be a lot of variation. Someone might use 5 W's in awesome. Someone might use 10 W's in awesome. Okay. So that would be a difficult job actually. Yes. So people are trying to understand the even the complexities in the text data. That's where research is going on. But we can understand. The machines would not understand unless we feed that specific information with the machines. Otherwise, that will be mentioned discarded as a junk phrase. Okay. So thank you. Have a good day. Bye.